This one is unique, being that it's really like a greenfield project because it is outside of the boundary limits of the mill. But it's a greenfield project at an existing paper mill. So this is a unique setup because the paper mill needs the steam and the utility needs the power. But the relationship between the two is a very unique relationship, and actually it's a great idea.
Well, what we do at 8 Flags, it's similar to combined cycle, but it's different. We have the gas turbine, smaller industrial gas turbine, just over 20 megawatts.
The gas comes in, fires the turbine creates power, which goes back to the substation, which then gets pushed back to the grid. And then throughout the combustion process, the turbine creates heat. Heat goes through the boiler, heats up the drum, creates steam, which the steam goes back and supplies steam to the paper mill.
They're using that heat in the steam to dry the paper in the process, so we're not throwing any heat away from that. This is not a simple project. They're building it on wasteland that had tremendous structural issues in the land itself to be able to get the foundations right, and then to be able to tie the connections all the way into an operating, 50, 60-year-old mill like that. There were many challenges like that. Even with FPU side, building the switch yard, moving the line across the marsh, and then also tying that into the chip yard and the CHP, there were some real complexities to get those poles set in that marshy land there. I think it was the geotech engineer said, this is like building on jello.
So to combat the bad soil conditions, we ended up installing just over 700 piling to hold up all the foundations and to basically shore up the foundation.
And so to make sure that we could brace it against wind, against floods, storm surges, was a huge challenge. And then we're tying into a mill that needs to run continuously and meet their needs and have the plant synchronize with their feed water needs, their steam needs, and be able to control them. We're tying into the FPU, and this is the only generation resource in their network. Teamwork was very essential. We did this project on a fast track. The way we define fast track is that we're just a step ahead of the contractor. When we start the design, none of the major equipment had been committed to. So when you commit to them, they have 6-8 weeks to make drawings so that we know what it's going to look like, but you can't delay the project by 6-8 weeks. So we started to assume things and started the design and make the adjustments as we would go along.
And by bringing in an experienced team, both Rayonier from the standpoint of the partner that they had to negotiate the agreements with, but then with C.R. Meyer, with NK Engineers, and others like this to bring the team together. They brought an experienced team together, coordinated by FPU. It's just been a winning team. And I think what's evident is the project out there and how smoothly it started up and how it's run today. We're right at 78 to 78.5% efficiency, and that's measured in a higher heating value, which is different from manufacturers. They use a 10% higher number. So it's 78, 79% efficient compared to a 50 to 55% efficient of the most efficient power plant built by utilities today.
We've got a low-cost source of steam coming into our facility that as we have operational changes, whether by design or not by design, by unfortunate circumstance, allows us then to take on steam, take on additional power as we may need to, and stabilize our operations. So it should, in effect, help us produce more product year-round for the customers who are looking for it in a very reliable way from us. So it really helps, I think, stabilize our operations and reduce our cost of our product.
And so this project is going to help make our plant more successful, make the island more successful, and again ensure that more generations of employees can raise their families here in our community and call Fernandina Beach home.